Topic 17. Now we're going to look at testing hypotheses about mu being the mean, population mean, as a matter of fact. You're going to notice this example is pretty well filled out. What I'd like you to do is pause the video. Well, actually, let's go through the problem statement first. And I'm going to have you pause the video and see if you understand where everything came from in A through F. So sun protection, most dermatologists recommend using a sunscreen with an SPF of at least 30. To test whether students at Cal Poly use sunscreen with an SPF of higher than 30 on average, I surveyed a sample of 48 students in an introductory statistics class. Now, I didn't ask whether you use sunscreen or not. We wanted to find out what level of sunscreen was used. So that's where you want to be careful that this is not categorical. So please pause for a moment and then come back and we'll do a quick recap of these, A through F. So A, observational unit, each intro stats student. So that's who I was asking. The variable, and it's going to vary from student to student, is what SPF sunscreen they use. And that's quantitative in nature because we can actually take those values. If let's say they did not use sunscreen, use SPF 0 up through SPF 70. And there were a few students, I believe, who used 100. Who were interested in general, and if you look specifically at the statement up here, it says students at Cal Poly. So we're interested in all Cal Poly students, but we're not going to ask every single Cal Poly student, so we're taking a sample. The parameter and symbol is mu because we're looking at that population. We're looking for that population average SPF for all Cal Poly students, and it's unknown. That's why we're doing testing. The sample were 48 students. The statistic is X bar. Remember, mu and X bar go together in the sense that the parameter relates to the population and the statistic relates to the sample. And that's the average SPF for all 48 students. And I haven't given you that value yet. Now it asks to state the null and alternate hypotheses. One thing I want to caution you on is that students want to use P. But here we're looking at means, so we must use mu, okay? We use sunscreen higher than 30, so we're going to assume, so 30 is our base. Higher than 30, we're going to do, for our alternate hypothesis, mu greater than 30. Remember, there's no overlap between the null and the alternate hypotheses. Do not state this in terms of X bar, because remember, X bar, we will know. We're interested in trying to get an estimate for or to test the parameter. Now, in the note says the sample of 48 reported an average SPF of 35.29 and standard deviation of 17.19. Key to remember here, these are statistics because it's based on the sample. What we'd like to know, if the null hypothesis is true, that the average SPF for Cal Poly students is 30, what's the probability that the sample average turns out to be 35.29 or higher or more extreme? Like we did for proportions, but we're not working with proportions, we're working with averages, means. So we need to use the one mean test. We're going to check whether the validity conditions are met. Either the population from which the sample is drawn is normally distributed, or the sample size is large enough. And remember, large enough is going to be greater than 40. And we have that here. We have n equals 48, so looking pretty good. Do we have a large population? That's the other thing that we should check. And we have more than 48 times 10. There are more than 480 Cal Poly students. That's true. So we're looking good. So we can say, okay, it is the central limit theorem. It's met. So if so, use an appropriate distribution to find a p-value. What we'd like to know is the distribution of sample means, the shape, center, and standard deviation, and then calculate how many standard deviations away the observed mean is from the center of the distribution. And then based on the p-value, make a decision and state a conclusion. So we're going to do these steps here, starting on the next page. So these are what we need to think about as we go. This is the summary for the one mean test. Like I said, we want to also make sure there's a large population. And we will do that on the next page.